right, let's look at these types of energy problems. So number 9 says, in fact, this should be actually number 6. Apologies for the numbering. Number 9, what is the mass of an object whose potential energy is 1,500 joules and is at a height of 12 meters from the ground? Okay, so if we're looking at potential energy, there's only one that includes a height and is asking for the mass. That would be PE gravitational, and that's equal to mgh. And we are solving for the mass. So we're going to manipulate this to divide both sides by GH. And so my mass is going to equal my potential energy over GH. So that's going to be 1,500 joules over, and we use 10 meters per second squared, and a height of 12 meters from the ground. So my mass will turn out to be 12.5 kilograms. Okay, number 10, what is the velocity of an object that is moving with a kinetic energy? So KE is 2,500 joules and a mass of 15 kilograms. Mass is 15 kilograms, and we want to know velocity. So our equation for kinetic energy is equal to 1/2 mv squared. If we're solving for v, to get rid of the 1/2, we have to multiply both sides by 2. And then to get rid of the m, we're just going to divide both sides by m. And then to handle the square root, we're going to take the square root of both sides. Okay, so square root of v. And so my velocity is equal to 2 times 2,500 joules over my mass of 15 kilograms. 15 kilograms, and take the square root of that, and I end up with a velocity of 18.26 meters per second. Again, we're not concerned all that much with significant digits on this. We're really just looking at, 1 or 2 decimal places. All right, let's look at my last example problem. So what is the spring constant of a spring that has a potential energy of 1,000 joules and has compressed 0.35 meters? So we want to know K. Our potential energy spring is 1,000 joules, and the spring has been compressed 0.35 meters. All right, so potential spring energy is equal to 1/2 kx squared. I need to solve for k. So that means I need to multiply both sides by 2 in order to knock down the 1/2. And I need to divide both sides by x squared. So k is equal to 2 times my potential energy over x squared. So it's going to be 2 times 1,000 joules over 0.35 meters, quantity squared. So my K value is going to be equal to, now this is not really realistic, 16,326.53 newtons per meter. So in this case, again, we're just looking at the way of manipulating things. Typically, you don't have a spring constant that high. Although, if anybody knows what the spring constant of your garage door spring is, that sucker is compressed crazy amount, to the point where you definitely want to hire a professional to help you out with it, because something really bad could happen if you try to mess with that spring. Anyway, that's that. I know this is not on your sheet. That's for the problem on the back side, and we will get to that in just a minute.